Or I need this section, there's one more. Remember that all of this started from back in chapter 3, I believe. We defined the image, once again, as 112, the mass of carbon 12 isotope, carbon 12 isotope has an exact mass of 1 AMU. And then we define a mole as the amount of particles of carbon 12 that were present in 12 grams of carbon 12. And then when those were counted, we got a summary. But we have this relationship right here, in which one atom of carbon 12 has an atomic mass of 12 AMUs. And then we bulk this up to 12 grams and assign that a value of 1 mole. And so this now becomes what is known as the molar mass. The mass of 1 mole of something. So for the elements, the molar mass of an element is the atomic mass in grams. Okay, so you go to the periodic table and find hydrogen. So the periodic table will tell you 4 significant figures. Hydrogen has an average atomic mass of 1.008 AMUs. That 1.008 comes from the periodic table. Yes. Well, if instead of 1 atom of hydrogen, we have 1 mole of hydrogen, then it's the same number, but now we're talking grams. You look up chlorine on the periodic table. And it'll tell us that it's 35.45 AMUs. Well, if instead of having 1 mole, 1 atom, we have 1 mole. Then AMU changes to grams. And so we call that the molar mass. We can extend this
Here.
to a compound. So say we have
Take a
aspirin,
picture.
acetylsalicylic acid. It's made up of those elements. So 1 mole.
Sorry.
You're welcome.
Of aspirin.
You woke us up.
Hydrogen and oxygen.
Ah. Just
Which
kidding.
one did you need?
I videoed it. It's all right. I'll go
I got
back.
a picture of it.
Okay, good.
One molecule of aspirin has 9 atoms of carbon. Each atom of carbon is 12.01 AMUs. So we multiply. So carbon contributes 108 AMUs to the total. There's 8 hydrogens. Each hydrogen has a mass of 1. So hydrogen contributes 8, each oxygen is 16, there's 4 of them. And so when we add up this total, then 2, 4, that's 0. So 9 and 6 is 15.
Can I ask a question really quick? I wasn't paying attention because I was writing stuff down.
No.
Where the heck did you get those numbers? I know this 9, 4, and 8, but I meant, yeah, those.
These are the atomic masses.
Oh.
Aren't they on the
On the periodic table. Oh, okay. Sorry. I'm trying to write and I stopped paying attention.
And we'll abbreviate periodic table.
Oh, okay.
Let me just check my math. I think it's off, way off. I need to line up my decimals. 180.
Well, not too off, you can just change the 8. I mean, that 2 to 8.
Okay. So 1 molecule of C9H8O4 has a molecular mass of 180.15 millimoles. 1 mole of
Go, Bessie.
C9H8O4 has a mass of 180.15 grams. And so in the chapter on gases, when we work on gases, the formulas work in moles. But then we have to change those moles into grams. And to do that, you multiply times the molar mass. And that molar mass, you have to calculate it from the periodic table. You have to look at the formula, add up all the components, and that's how much one of something weighs. So we're going to have that relationship between mass and moles using the molar mass. Ask.
When did you shave? When did you shave?
Yesterday night, yesterday evening.
Why?
It was just too long, and I was gonna trim.
And you made a mistake.
And yeah, it's better to start from scratch then. But usually I do about twice a year I do shave the whole thing.
Why?
Is
Is there a reasoning behind it, or you just do it?
No,
But you gotta do it
It's
before
actually healthy
November.
to shave it off
Yeah?
every once in a while.
and then it goes fairly quick. My Christmas, my only Saturday.
So over here, you sig fig rules, right? That's why you went 180.15?
Right. So well,
To the
because
nearest,
of the
yeah.
addition.
When you add, it's after the decimal, right?
Right.
Okay, and you
so
go to the
that's
lowest.
thousands and the hundreds is the least.
So,
So to the.
okay. Stupid sig figs. Atomic mass.
Oh, one reminds me late all the time.
Oh, really? Yeah, no, I have that, like, remind everything.
Well, but I also like, I'm like, remind me later, yeah, just remind me to remind again. When I'm not doing it.
Okay. So So since, remember, any relationship that occurs at the particle level always extends to any term that represents a number. Okay, so that's what we did last time in terms of, we had, if we have one of these units, then it's a 9, 8, 4 scenario. But say we had a dozen of these units, it's still 9 dozen to 8 dozen to 4 dozen. If we have moles, then it's 9 moles to 8 moles to 4 moles. And that's always going to be true, not just in a formula, but it extends to a chemical equation. So as we take a look at the formation of iron 3 sulfide. The balance equation tells us that 2 atoms of iron react with 3 atoms of sulfur to make 1 molecule of iron 3 sulfide. So it's that 2:3 to 1 ratio. Well, that 2:3 to 1 ratio extends to moles. So 2 moles of iron react with 3 moles of sulfur to make 1 mole of Fe2 ester. So any relationship between individual units extends to the moles, or to any term that means it. So the mole is the one that we use. Because in a chemical reaction, atoms are neither created nor destroyed. Mass is conserved because every atom has its own mass. Since we're not creating any new atoms, then the mass should not increase. If we're not getting rid of any atoms, then the mass should not decrease. So chemical reactions conserve mass. That does not mean that there aren't processes in which mass can be created and destroyed. And there are nuclear processes. So when you have nuclear reactions, mass is not conserved. But in chemical reactions, all we're doing is rearranging atoms. So there is no change in the total mass. The mass of products is equal to the mass of reactants. So in this example, we have silver. One mole of silver is 107.8 grams. 1 mole of sulfur is 32.1 grams. And then we're making silver sulfide. And so silver sulfide, when you add them up, we have 2 silvers and 1 sulfur.
Twice the number of silver. Mm.
And when you add those values up, you'll get that total, so 47.8.
Oh.
And so mass is conserved.
That's not too hard. That's not bad.
And so those values on the bottom, we get them from the periodic table. Or if we had to look them up. Okay. So each silver is 107.9, multiply that by 2, and that gives us 215.8. There's only 1 sulfur, so 1 times 32 is 32.
And it's only gonna go on this one,
Well, on that scale. But that's the limit of the scale. Scale in the labs can measure to 2 decimals. If you use the ones that are covered up, then you can go to 4 decimals. The periodic table that is uploaded to my PCC, my PCC.edu, has usually 4 or more decimal places. For any given test problem, if you keep it to 2 decimals, you should be good.
Oh, before I forget to ask, do you have lab tomorrow?
No lab tomorrow. Or
So if we don't come to lab tomorrow,
Friday that we have off after Thanksgiving?
No. There's no Thanksgiving weekend.
Okay, good.
Now, technically, if you have a weekend class, Saturday or Sunday,
You can do the class.
right, that's not part of the holiday. Now, most instructors take that day off, so you get the day off because they're taking the day off. But strictly
If you
speaking,
have that one
terms,
instructor who says I'm not
well,
cheating,
what it boils down to is to whether the instructor
is behind.
thinks he's gonna get in trouble or not.
So, like, that is canceled for?
Yes,
Okay.
yes, yes. I'd love to. Which, need to let the lady in charge of the map. But yeah, those weekend scenarios and then evening scenarios like the Wednesday before Thanksgiving, something like that.
Oh, man.
A lot of instructors will cancel class, and then usually they want the time off. But if they, every now and then, deans get wind of it, somebody gets in trouble. And the thing here is that if you're an adjunct instructor, a part-time professor, you don't really get fired, you just accidentally don't get assigned a class. You know,
Accident.
The next semester.
yes, and so that's kind of like a way to work around. Not that you need to hear Texas, because it is a work at Will's state.
Yeah.
I had one instructor
But,
that never showed up. It was a 7 a.m. class, 7 to 8. I'm like, can you send an email at least? I can sleep in.
Yeah.
And then sometimes he can get there, like, did you have the 15 minutes to get to like 7:13 when he did show up? But we all got an 8.
Having a 7 a.m. class, the class is strange.
And you know what, I always like sign up for those classes, I'm like, I can do it, and then I'm always like 30 minutes late every class, like, crap.
I'm late to my afternoon classes, and I'm always early to my early
Like,
morning ones.
micro, I was always
Oh,
on
yeah.
time for micro, and yeah, now my anatomy class is Thursday, I can never get to it. Like, never, yeah, I never get to one on time.
They used to, and I don't know if they're still,
But he doesn't care.
I know in science, they don't anymore. In trying to target working individuals, you know, because we work 8 to typical hours. For a year, they tried out 6 a.m. classes.
Well, there's
Oh, that's right.
6 a.m. class at my
There's very few of them still, though.
And then that was the idea, you know, you go to class and then go to
Work.
work right after that.
But nobody was showing up.
You know, and the thing is, usually if you're a working individual, you're also a parent.
Yes.
So you can't be like,
Even, when I took night classes, it was still, even though I was like up and, you know, like, but after work, it was so hard to get to sometimes, I was like, oh,
I
I can't do this.
after 5 a.m. If I don't work time, but I'm just like before, it's not gonna be.
I think your day's more productive if you do stuff in the morning.
Yeah.
Mm-hmm.
So real quick, in terms of the relationships. So that 2:1 ratio, it's in terms of atoms and particles. And then you can bulk it up into units. So if you think about it, in Spanish, it's the word centena, which means 100 units. So if we're working in centenas, then you have 2 centenas here, 1 centena there, 1 centena there. Okay, so let's 2:1 ratio. And then that extends to moles, 2:1. And then if we want to find out the mass, then we go to the periodic table and multiply those units times the masses we get from the periodic table. If it's an atom, then just get it straight out. If it's a compound, then add them up, and then that's the total that you would multiply. Okay. Now those relationships become ratios that allow us to complete the recipe. And that's what these are, recipes. So, 2 eggs plus 3 slices of bacon. And you get 1 big breakfast. Okay, that 2 to 3 to 1. That's 2 to 3 to 1.
But it still has the same number of elements, like, on each side.
Yes. The thing is that now we're gonna be starting with some amounts. So you buy a package of bacon that has 10 slices. How many complete breakfasts can we do? Well, that ratio is I need 3 slices of bacon for every 1 breakfast. And then we end up with 3.3 breakfasts. In principle, well, we only have enough to complete 3. But that ratio allows us to do those types of calculations. If you have a box of dozen eggs, then 12 divided by 2 is 6, so we can do 6 breakfasts. And that's where the ratios. You have a party of, I don't know, 8 individuals, and they all want the same breakfast, then we can calculate how many pieces of each component we need. So the clients come in, they all order the same thing. Well, I need 16 eggs and 24 slices of bacon to.
And then you divide it by 3 to figure out how many big breakfasts total?
Well, no, in this example, we started with how many big breakfasts we need.
Oh, okay.
Okay, this
I
is
thought
how
those were
many-
people, sorry.
And each one
Oh,
orders
yeah,
one.
yeah, okay.
No sharing. Okay. So consider the following equation, a mole to mole factor for hydrogen and nitrogen. Okay. Now, the order in the sentence is the order in the fraction. So if they're giving it to us hydrogen and nitrogen, then that means hydrogen is on top and nitrogen is on the bottom.
So egg?
So
No.
3 to 1.
I'm sorry.
Oh. I should also be the inverse of this.
Wait, what?
Now, it should be 3 moles of hydrogen and 1 mole of nitrogen. Which actually is not that. But usually the sequence in the sentence should be the sequence in the fraction. When you're doing ratios.
Okay. So the answer's not there.
And then for number 2, that one would be B. So ammonia on top, hydrogen on the bottom, and then we have 2 and 3.
What's this?
Now, for number 1,
Wait.
B, well, it's not the ratio that we want. B is still a valid ratio.
Because you can always do like the H over 2, and then you can do the inverse too to find some
Right.
other. That's like when we did conversion factors.
Exactly. And that's exactly what these are. Going back to chapter 2. Let's convert, these are conversion factors. So how many moles of FeO3 can be formed from 6 moles of oxygen? So 6 moles of oxygen is what's given. we want to cancel oxygen, and the question is asking us for Fe2O3. Then we just go to the balance equation and put in the numbers. The oxygen has a 3, Fe2O3 has a 2. That's what we do here. So moles of oxygen cancels, leaving us with moles of Fe2O3. Because the mole on the ratio, on those ratios, is based on the particles, that's considered a counting number. So the mole ratios are exact. That 2 to 3 ratio, that's exact. So in terms of significant figures, we have 2. So we have 12 moles of oxygen. And the question is asking us for how many moles of Fe? And we go to the periodic table, oxygen has a 3, Fe has a 4. Oxygen has a 3, Fe has a 4. Moles of oxygen cancels. Leaving us with moles of Fe.
So basically it's just knowing the moles, the formula, and then just doing this.
So this is the starting point, this is given. And then you're going to get this from the balance equation.
Because it's wanting to know, like, because they're upping how many moles of O2 you have. They're trying, so they want you to figure out how much more you would need for the iron. Like how many more moles.
Oh,
you
to
need
balance
yeah,
it.
To balance it, yeah.
Oh.
And then the ratio, what you're given, we already know that, so obviously that's not what we want. So that's what we want to cancel. And whatever the question is asking for, that's what it would be. And once again, all of these, they're just residues.
So you got 16.0 because you added 12 plus 4?
We multiply 12 times 4, which is 48, and divided by 3. 48 divided by 3, and then that gives us 60.
Thank you.
So in this bracket thing that I'm doing, that's kind of what that, mathematically, that's what it represents. Okay, it's just fractional multiplication. I just cannot do the brackets. Questions? some review questions. And so, chapter 6, and then from chapter 7, 7.2, 7.1, 7.6, which is basically the mole, Avogadro's number, and molar masses. And chemical reactions. Types and elements. From chapters. Then chapter 6 is your nomenclature and everything that leads to the nomenclature together. Make compounds. So, what is the formula of a compound that contains sodium and phosphate ions? And you're given the charges. So how many positive ones to cancel the negative 3?
3.
So we end up with B. So there's a nitrite, and a nitrate. Your ites and eights, they're in your handout. They're polyatomic, they're groups. And so these you would look up. But if it ends in IDE, it's an element from the periodic table. So what element does NIT sound like?
Nitrogen?
Sounds like nitrogen. And nitrogen is in group 5. Group 5 nonmetals have a charge of
Negative 3.
group 1 plus 1, group 2 plus 2, group 3 plus 3. Same cadmium plus 2, silver plus 1. Group 7 nonmetals negative 1, group 6 nonmetals negative 2. Group 5 nonmetals negative 3. So nitrite is in 3 metals. So that's E. And notice that the nitrite and nitrate are also on the list. Okay. So number 1, you were given the charges. For number 3, you're not given the charges. Magnesium's in group 2.
It's going to be positive 2.
Sulfur's in group 6.
Negative 2. So it's going to be magnesium sulfate.
Because they cancel out.
And it seems like it was ages ago.
I know.
It was like 2. It does seem like. Okay. Hydrogen sulfide has a shape similar to remember that elements that are in the same group have the same number of valence electrons. And the shapes are based on the valence electrons. Right? So sulfur's in group 6. So any combination of 2 hydrogens with any one of those has the same shape. So H2O, H2S, H2SC, H2TE, they all have the same shape, which is that.
What about number 4? I think we might have.
Oh, I skipped
tetraiod.
4, sorry. What is the, okay, so for number 4. Metal or non-metal?
Non-metal.
Non-carbon.
If it begins with a metal or ammonium, it's ionic, and we're dealing with charges, okay? But if it's a non-metal, it's just prefixes. So we have carbon and iron. How many carbons?
None. 1,
One. How many?
4.
4.
It's easy. Okay.
Number 6. We have Cl2. Is Cl a metal?
Metal.
Okay. So if it begins with a metal, then it's ionic, aromatic. But it doesn't begin with a metal, so we can cross out ionic. Right, so Cl is a non-metal, so we have 2 non-metals.
It's gonna be a non-polar covalent.
Whoa. Good job.
Well, because it's the same element, so it's not gonna be polar, because they're not gonna unequally share the electrons. And it's a covalent because it's 2 non-metals.
So because it's 2 non-metals, it's covalent. And then now we need to decide, is it polar or non-polar? Well, they have, because it's the same element, they have the same value. So they cancel each other out. So it'll be non-polar covalent. Anytime you have 2 non-metal atoms, and not 2 non-metal elements, but anytime you have 2 non-metal atoms, if they're the same, non-polar, if they're different, polar. Okay, so the charge is protons minus electrons in that sequence. Protons first, electrons second. So protons minus electrons, 13 minus 10. Okay, and the order is important. Protons minus electrons, not the other way around.
But you can still just switch up 13, right?
Well, if you do 10 minus 13, you get a negative 3.
No, like switch up 13 on the periodic table.
Oh, okay, so if we want the symbol, yes. So right now it's just asking for,
In general.
yes. But if we want to do the full symbol, then yes, we would go to the periodic table, look at atomic number 13, and that would be aluminum. And then with a 3 plus on top. Just the best electron dot structure for CH2CO2. Okay, and here, just, we don't have it. Follow the steps. Step 1, do the skeletal structure. The first element is the one in the middle. Everything that follows is attached to that central atom. So we have 2 hydrogens and 2 Cls. Step 2, count the number of valence electrons. So carbon is in group 4, hydrogen is in group 1, chlorine is in group 7. So we have 6 plus 14. 20 electrons to work. Step 3, give 8 electrons to the outside elements except for hydrogen. So each one of these chlorines gets six electrons. So we have 8. Step 4, if there are leftover electrons, we put them in pairs on the central atom. That's 8, plus 8, that's 16, plus 2, that's 18, plus 2, that's 20. So we've used up 20 electrons, we have 20 available, there's no leftover ones, so no extra lone pairs. And last but not least, check the central atom for 8. So we looked at carbon, 2, 4, 6, 8.
So D.
That's it, we're good. Now, remember, on paper, it looks flat. In 3 dimensions, it's tetrahedral. It's sticking out. So the order of the hydrogens and Cls is irrelevant. Okay?
Aren't you missing 2 dots? On Cl. No, 2 dots. There you go.
So it doesn't matter where the hydrogens and Cls are located. As you look for the similar structure. As long as the Cls have the 8 electrons, the carbon, no lone pairs, and hydrogen lone pairs. And so the answer is B. A has the right starting point, but it's missing the lone pairs on chlorine. And then there's no double bonds. We're looking at D. Okay, so for covalent bonding, we're looking for 2, what kind of atoms? 2 nonmetals. And are they transferring or sharing? Sharing. So ionic, there's a transfer, gain and loss. For covalent, then we're sharing electrons. So let's see, A, atoms of different metals, so that's wrong, no metals. B also says that we're metals, so we can cross out B. So C, atoms are held together by sharing electrons, that's true. D, we don't have any charges in covalent compounds. And noble gases don't combine with anything. So that leaves us with C. Atoms are held together by sharing electrons. And then as we saw a little bit earlier, water has what type of shape? It's bent. Number 11. Nitrogen, metal or non-metal? Okay, so if it begins with a non-metal, we use prefixes.
Nitrogen trichloride.
So nitrogen trichloride. D.
If it begins with a non-metal, if it begins with a non-metal, it's prefixes.
If it begins with a metal, then we're dealing with charges, with ions. And then remember the prefix mono, we reserve it for oxygen. Okay, so aluminum, metal or non-metal? It's a metal. So for ionic compounds, name the metal and name the negative ion. So Al stands for
Aluminum. Dialuminum. No.
what
Aluminum.
follows. It's a group. Look it up. Make sure you have your handout. If it's in parentheses, you look for what's inside the parentheses. So you look up SO4. When you find SO4 on the handout, it's called a sulfate.
So it's
So it's
trisulfide.
aluminum sulfate.
Oh, just kidding.
Name the metal, name the non-metal, that's ionic.
Okay.
And then now, do we need a Roman numeral? So group 1, group 2, group 3, zinc, cadmium, and silver do not need a Roman numeral because we're supposed to know what they are. Group 1 is +1, group 2 is +2, group 3 is +3. Zinc and cadmium are always +2, silver is always +1. Because we know what they are, we're going to need a reminder. The Roman numeral is there when it can change. So aluminum's in group 3, it's always +3. That's it, aluminum sulfate. Not complicated.
So it's
Not to worry about the little numbers. They call it subscripts. In ionic compounds, we do not use prefixes. Prefixes are for covalent compounds, two nonmetals.
So it would be E.
Yes. AT sulfate. Yes. Aluminum sulfate. What is the correct formula for the oxide ion? So if it ends in ID, we go to the periodic table. Now there's those 5 that you can keep an eye on. Cyanide, hydroxide, azide, peroxide, thiocyanide. And then on your hand. There are the IDs that are not nonmetals. They're polyatomic. But all the other ones, all the other IDs are nonmetals. And the 5 that you need to keep an eye on, they don't sound like any nonmetal anyways. Okay. So azide, there's not an element in the periodic table that begins with AZ. Peroxide, there's not an element in the periodic table that starts with PR. So even if you look for it, you won't find it. Okay, so oxide means oxygen. Oxygen's in group 6. What's the charge for group 6 nonmetals?
Negative.
-2. Group 7, -1, group 6, -2, group 5, -3. Okay, so we have B. Okay. 14, which of the following compounds contains an ionic bond? Ionic compounds always begin with, okay, so which one of those begins with a metal?
Calcium.
Calcium. Yes. So A contains an ionic bond. MgCO2. Mg, metal or non-metal?
No.
So name the metal, name the negative ion. Non-metals end in IDE, so chlorine becomes chlorine. Name the metal, name the negative ion, and then determine if you need a Roman numeral. That's it. So do we need a Roman numeral? No. We know what magnesium, or we should know what magnesium is because it's in group 2. Group 2 is always +2. So magnesium chloride. So D. D. We start with a skeletal structure. First element in the formula is the one in the middle. Count the number of valence electrons. Oxygen is in group 6, chlorine is in group 7. We have 2. Step 3, give octets to the outside elements except for hydrogen. 2, 4, 5, 6. Step 3, leftover electrons, place them on the central atom. we have 8 plus 8, that's 16. We have
24.
20.
4.
Okay, and that's 2 pairs.
And why don't we double that bond? The other 9, why didn't we just use the other 9 instead?
Okay, ask me again. Why don't we do it?
The double line, I forgot what they're called.
When do we do that?
When we have
So
more,
remember, follow the steps. Okay. So just follow the steps in sequence.
like if we
Follow
needed,
the steps in sequence.
That's what if we needed more, right? If
we needed more than 4.
Okay. Follow the rules. Okay, so you don't do double bonds or triple bonds up until the very, very end. And only if we need to. Okay, so don't force double or triple bonds. Do not force 8 electrons either, unless we're at the very bottom. It's okay not to have 8 electrons too. So if you follow the steps, you can't go wrong. And this takes care of any exception. Like you can see, this incorporates any odd stuff that can occur. It just works itself out. So after step 4, where we put the leftover electrons on oxygen, then step 5 is check oxygen, check the central atom for 8. Does oxygen have 8?
Yeah.
Yes, that's it. We're done. If you do double bond, then how many electrons does oxygen have? 2, 4, 6, 8, 10, 12.
Well, what if you just did the double bond instead of the lone pair?
So you did this. Okay, the only elements that can double bond are these. That's why we have to keep an eye out for this over here.
So oxygen would have to attach to like.
So it's to another oxygen or a sulfur or a nitrogen oxide. So those would be the only choices. At this level of chemistry. There's other weird stuff that happens in what are called complex molecules. And they're called complex for a reason. You can see up to like 6 bonds between 2 metals. That's stuff I don't have to worry about. Okay. All right. So what's the answer?
D. Correct?
D?
Wait, yeah, D, delta.
Okay. Yeah.
What does it say down there, double,
Or triple.
triple? Okay.
As needed to get to it. Okay. But for carbon, nitrogen, and oxygen, you cannot be above 8. For sulfur, you can. And actually, sulfur, like if you have a choice of 7 or 9, sulfur will take the higher one. So aluminum is in group 3. Group 3 metals have a charge of +3. So in order to go from 0 to a +3, what has to happen with the electrons? Have to lose 3. Yes. So A, when aluminum forms its ion, it loses 3 electrons. Which of the following compounds contains an ion with a positive 3 charge? Group 2, group 1, group 1. So we can cross those out, which just leaves us with those choices. What's the charge on Cl?
-1.
It's group 7, that's -1. To cancel -1, you need a positive 1. -1 times 3 is -3. To cancel -3, you need a positive 3. So FeCl3.
What the heck?
A blank is the smallest neutral unit of 2 or more atoms held together by a covalent bond. So, this is a water what? Molecule. Water molecule. Okay, so for interactions, if you have an ionic compound, then you have ionic interactions, ionic bonds. If you have a covalent compounds can either be polar or non-polar. If it's non-polar, then you have dispersion forces. If it's polar, then you have dipole-dipole interactions. Okay, but for the dipole-dipole, there's a special type of dipole-dipole, which is hydrogen bonding. So if you have hydrogen attached to oxygen, nitrogen, or fluorine, then we have we have hydrogen bonding. Okay. So sodium fluoride, NaF. What type of compound?
Hydrogen bonding. Sorry.
For number 20. So sodium fluoride. Is it ionic or covalent? Begins with a middle. It's ionic. So the only choice is ionic bonds.
What the heck? Oh, N, not N. Okay, never mind.
So number 21, this is the stuff that we just covered. Na is Avogadro's number. we're looking in, that's my symbol for molar mass. Which we get from the periodic table. So from mass to moles, we divide by the molar mass. From moles to mass, we multiply times the molar mass. From moles to particles, we divide. We multiply times the Lagrange number. From particles to moles, we divide by the Lagrange number.
Ugh, what a mess.
So for number 21, we're given the mass of water, 75 grams of water, and they're asking us for the number of hydrogen atoms. Okay, atoms are particles. So before we can get to particles, we need to convert to moles. Okay. And from mass to moles, we divide by the molar mass. Actually, I think I probably won't have a problem like that in the test. That requires that many steps. But we'll work it. So, we convert to moles by dividing by the molar mass. Okay, that 18 comes from adding hydrogen and oxygen on the periodic table. Oxygen is 16, hydrogen is 1. 1 times 2 is 2, plus 16 is 18. Okay, those numbers come from our periodic table. Now, the question is not asking for water particles. The question is asking for hydrogen particles. In 1 unit of water, how many hydrogens do we have? 2. And now that we have moles of hydrogens and we're looking for atoms of hydrogen, we multiply times Avogadro's number. Grams of water, grams of water, moles of water, moles of hydrogen. So 18, that's 20 times 4, that's 80, so it's about 4 times 2 is 8. 8 times 6 is 48, so 4 point something. Maybe a little bit about 4.8, so about 5. So I promise I won't have one that has that many steps. But you will have one step once.
Okay, so.
If it's an element, you just look it up on the periodic table, the molar mass of potassium. So you look up potassium in the periodic table, and potassium will be 39.1. Now, potassium is atomic number 19. That's the atomic number. So don't take D. Okay, so if there's two numbers there. You'll have a 19, and then it has the 39.1. One's the atomic number, the other one's the mass. We're looking for the mass. So the mass is at 39.1. You look at lithium on the periodic table, and it has a mass of 6.941 grams. Okay. And that's for 1 mole. Now, we don't have 1 mole, we have 1/10 of a mole. So, if we divide by 10, what do we get?
B.
Gonna get B. 0.69. So number 24, calculate the molar mass of magnesium chloride. So magnesium chloride has 1 magnesium. And 2 Cls. Go to the periodic table, look at magnesium, has a molar mass of 24.3. Look at chlorine, molar mass of 35.45. Okay, so these numbers, these 2 numbers come from the periodic table. 1 times this, 2 times that. Then we just add them up.
So B?
And kind of, and you only take into account the 1 magnesium, and forget to add the chlorine. If you take the chlorine, forget to add the magnesium. Okay. If you, by some mistake, end up adding 2 magnesiums and 2 chlorines. Okay. And so, let's see, number 25, and this one does go back to the order. Given the following equation, what is the correct form of the conversion factor needed to convert the number of moles of oxygen?
C? 2, 4? 2, oh no, wait.
2 moles of Fe2O3. We want to convert this to this. That means that this is given. And we're looking for this.
Okay.
So we want the oxygen on the bottom. And the Fe2O3 on top. So that leaves us with only 1 choice. Actually 2 choices. No, yeah, only 1 choice. Which is B. No.
You want D?
It's E,
No.
right?
No?
I thought C.
And
Wait.
because this is,
Okay.
It's B. B is a B.
now because of the wording, this is not the sequence.
Oh,
Because of the word from. Or not from, but to, excuse me. Conversion rate to convert the number of moles of O2, that's what you're starting out with. Okay, you want to convert moles of oxygen. That's what you're given.
yeah.
Oh, okay.
2 moles of Fe2O3.
So A then.
So we need the oxygen over here to cancel it out.
Oh, so I was right. No,
B. No, it's B.
B. Oh, never mind.
Yes,
Where 2? 3 come from. What?
well, now that we know what goes on top and what goes on the bottom, now go to the balance equation. What's the number in front of Fe2O3?
2.
And in front of oxygen?
Oh. Do you drop one, like your lowest test? Like, do you do that? Okay. Good.
We do get our lowest test grade though?
You have to drop, well, there's 4 in class, like.
How many more tests do we have?
3 and then 4 will be close to the end of it.
And 4 is, wait, were you the one that says it's a take home or was that my micro?
The final is a
Is it
take.
take?
Oh, so we have one more exam and a final. After this one.
Yes.
Okay.
Now, a lot of students end up, if you like your grade after exam 3, a lot of students just don't take exam 4.
Okay, what's worse, exam 3 or exam 4?
Never the same, because they will contain
Math.
Oh, Jesus. You're gonna keep me out of nursing
Is there
school.
any way you
I'm
can
gonna
take
bother
out the
you.
math from there?
I know, what the heck, man? I don't need to know moles to be a
You bet
nurse.
To the left.
The most common nursing
Jesus.
errors are
Medication error.
medication errors.
This is why.
Oh, I'm not
Medication
gonna
errors, for the most
prescribe
part,
until I'm
there's
a
2
master's
types.
degree.
Either the wrong medication
Because of the name. The wrong person.
or
All
the
of the
wrong
people's gonna
dosage.
die, they're gonna die.
I know. Why are we afraid of death? It's not bad.
That is.
Like, doses, boo-boo.
I hate this.
I hope you're never my nurse.
I'll tell you a few things. You know, the whole hospital acquired infections. Okay? That should never happen.
But that's
If
one
you're-
of the number 1 causes of death. I would argue is that people with guns.
And
More
it should
people
not be
die from
happening.
medical errors.
And it should not be happening.
200,000 people versus 30,000.
Wait, what was number 27?
What's the question?
What was number 25?
Well, there was still some more, but,
You're just over it. I'm over it
the
too.
answer should be at the end.
They are, yeah.
Yeah,
I see
yeah.
it now.
So, okay.
Ugh.
No.